I'll handle that.
Okay. Mic check. Hello.
Hi, Tony.
We can hear you.
Hi, guys.
Hi.
Hello?
Ajahn, we can hear you.
Okay, thank you.
You got a little echo on your side, Ajahn, from your speaker, probably. If you have a headset, it'd probably be better. All right, the timer kicked. It's 10 o'clock. Well, somewhere. What is it, 1400 UTC?
Yep, that's exactly what it is.
Excellent. Want to get started?
Sure.
Okay, let me, I guess I'm the one that should be sharing. Oops. Probably should have had this up from the start. Hi, everyone. Welcome to the first interim for LSR in 2022, probably the last one as well. These slides were put together by Yung Zhen. She's the secretary, also the chair for our working group, I think now. Thank you for that. Here's the note well. And what it says is that by participating in this meeting or in the IETF in general, you agree to follow the processes and policies. You're aware of the IPR rules. And you agree to work respectfully with others. There's more to this, and you can read it on these various documents that are listed in the slide. So here's the agenda. These are primarily, well, a lot of these are presentations that were not able to be given at 1:14 because we didn't have enough time in our 2-hour block. Does anyone have some agenda bashing? Want to bash this agenda? Okay. Well then, let's get started. Peter, I think you're going to be first up.
Yeah, sure, Chris. Can you hear me?
Yeah, I can. I'm going to pass you the control of the slides.
Okay.
Is it showing you the deck I'm sharing, or is it showing you a choice?
It is showing me the deck you are sharing.
That's weird. Yeah. Okay.
It says Christian
happens?
Hope slides.
No.
Nothing.
Take slides back. Now what does it show? I'm just curious.
I still see your
Okay.
slides.
Yeah, right now I'm looking at the selection list, so I wonder if it would give you that. Let me, so I have to be the one that starts, I guess, picking.
It says a new slide deck has been shared, but I still see the agenda.
Yeah. I'm not exactly sure what's going on.
Chris, maybe you should try to stop sharing the current one first.
We can just,
Yeah,
okay.
so I did that. And then I click share. Okay, now it's giving me the choice. So then I pick this. So I have to pick the slide deck and then pass it to Peter. That's strange, but okay. You should have your deck.
Yeah, seems like I can even slide it up. All right.
All right. Thanks.
Hi, folks. Good morning, good afternoon, good evening, whatever the time is at your location. I'm going to cover the simple draft for the Flux Algo reverse affinity that we put together with the co-authors listed here. So what are we trying to do? So today with Flux Algo, we have support for affinity related constraints, which is exclude any, include any, include all. And affinities as such are advertised as a link attributes, and as such, these are unidirectional properties. And these affinities are being used in one direction, basically in the direction that we calculate the SPT. So we only use the affinities in the forwarding direction of the SPT. What we are proposing is to allow the usage of the affinities in the reverse direction of the link. And it can be either set manually or it could be set based on some, measurements or some other logic, whatever the implementation is willing to do. So, well, I used to have a animation here, but with PDF, I don't think this is going to work. So basically, an example of the use case here is the primary pass between 1 and 7 is 1237. Now there is some input error rate measurement happening on the 3, and that 3 can actually figure out that it is receiving some input errors, and if it crosses the number of errors crosses the threshold, the 3 can set the affinity in the direction 3 to 2. And then if we use such reverse affinity as a constraint in the Flux Algo calculation, then basically what the 1 and 2 and everybody else will do is it will avoid the link. So the pass will be 1, 2, 4, 3, and 7, avoiding the link with the input error rate. So that is the high-level concept. This is being done or requested for a specific service, which we call an ultra-reliable service, where the user really is very, very sensitive to any drops in the traffic. So the mechanics that we are proposing to add 3 new sub-TLVs into the FAT, which is an exclude reverse admin group, include any reverse admin group, and include all reverse admin group TLVs or sub-TLVs. This is analogous to the existing ones which are using in the forwarding direction. And obviously, it will be defined for both IGPs. And in the calculation of the flex pass, we add the 3 rules, which are very similar to those which are used for the existing affinities. It's just that the affinities we are going to take is in the reverse direction of the link that we are adding into the SPT. So basically, this is a new draft. We are welcoming any comments, ideas. You like it, you don't like it, whatever. And if the group decides this is a good idea, then we would like to take it to the working group as a working group item.
Hi. So I think it's a good idea. I have a question. So the reverse affinity, this is a new attribute, right? It's not using an old one.
So this is, attribute from the link attribute perspective, this is not new. This is just the affinity which is being advertised as it is. It's just that today we never use the affinity on the reverse direction of a link. We always use and consider affinities in the direction of, from A to B, if that is the path that we are calculating, but never from B to A. But we are not defining any new link attribute. What we are defining is that during the SPF, we will use the affinities, not only from the forwarding direction, but also from the reverse.
So the reason I came at this from a specific thing. I was going to say we should call this the receiving affinity, not the reverse affinity. But given what you just said, it truly is the reverse affinity. Right?
It is
so
the reverse, yes.
So if 3 to 2 changes from blue to red, that's going to
Then
affect
I want to exclude 2 to
traffic
3
from
link, basically.
7 to 1, right?
2 to 3. So
no,
I
but I
can
mean,
go back to
without
the picture.
without this, yeah, go to the thing. So without this, right? Not considering this extension, 3 is going to change 3 to 2 from green to red. Then traffic
And
from
nothing
7
will
to 1
happen.
is 7 to 1 traffic will change, right?
Yes, 7 to 1, but not 1 to 7. But we want to send
Right,
it. We
right.
want to
But
change 1 to 7. Yeah.
yeah, but 7 to 1 will change it. So
Well, not
it's like
necessarily. It depends. It depends if you have affinity. So you can the constraint for forward affinity and reverse affinity is going to be independent. So if you have the constraint saying red, existing exclude or include red, then the 3 to 2 change would affect 7 to 1 traffic. If not, it wouldn't. So these are
right, but
independent.
so the reason, I mean, what I'm trying to get at here is sort of hinted at with my name change, right? Receiving affinity. I think it would be useful because you're making the change based on input error rate. That's not output error rate, right? And you can actually have this in the field where you have one fiber that's degraded, right? Where the
One
so
direction,
3 to
yeah.
2, yeah, 3 to 2's transmit is fine, but 2 to 3, the receive on 3 is broken, right? And so there's a real usefulness here of being able to say my receive is degraded, but my send isn't, right? And by overloading the reverse affinity, you're affecting both directions. Whereas I think it might even be more useful to be able to say, to be able to comment on the receive. We did this at a previous job, right, with something else, but just wanting to degrade things based on received error. So it is useful.
Right.
But I'm wondering about its becoming, it's having a bigger effect than maybe it should. It could be finer grained. That's it.
Okay, sure.
I guess I'm up. I looked at this and I looked at the existing things we had, and this the reverse metric and the reverse TE metric, and this is a little bit more flexible, and it extends it to the flexible algorithm so you can only do the traffic reroute for certain prefixes that are using a flex algorithm. So I thought it made sense in the same vein as we already had those two. This just seems like a natural extension to flex algorithm.
Yeah. When I said we did it with something else, that's what I was thinking of. It was reverse metric.
That's for everything on the link within that topology. This is just for the prefixes using the flex
Yeah. So the idea is that you can define a flex algo for the specific service, which is this ultra reliable one, and then you can use the flex algo mechanics to achieve the service you want.
Right. Yuzhang?
Hi, Peter. Just a clarification question. What is the input error rate mean in this figure? Is that packet loss rate?
Well, it can be anything you want. So basically, whatever the 3 decides to claim to be an error, it's really a local method on 3. It can be a number of input error packets received over a certain period of time, or can be whatever. You can even go and get some notifications from the line card at the optical level, whatever it is. We don't specify what that is, but it can be anything that the implementation decides to track on the receive side.
Okay. Understood. Thank you.
Sure.
Okay, the queue being empty, seems like we could have some more discussion on the list. Some of these comments. Seems like decent work, though. Some interest in it. Thanks, Peter. All right, next up. Are you in a lab? Sounds like you're right next to an AC unit or something.
Or on a train.
Going with lab, he's coding up the presentation.
Where is the noise?
Oh, now we got some bass. Maybe he's at a concert.
Ready? And begin.
Yeah, that audio is pretty bad.
Yeah, I think someone is there's a background noise, right? You can hear me, right? This is Louis.
Louis, I can hear you. Zhang,
Okay.
I'm just going to cut that there. Sorry.
Okay, that's
okay.
All right, now. Okay, Louis, you're going to present?
Yes, that's right. Okay, thank you.
Okay.
Okay.
You should be
able to control, right? Okay, let me try. I haven't tried. So this is the first time I try to present in this forum. My name is Louis Chen, and then this is a kind of draft is a draft I go over with Christoph and Juniper Networks. It talks about how to advertising offset for Flux algorithm, which is a target for adjacencies and also for prefixes as well. So this is the IGP extensions for that one for both ISS and Ospf. So we know that in Flux Algo, there's a draft already talking about how to advertise per Flux Algo adjacency. Okay, that is the method. I mean, using a new label or new index. For Flux Algo in this case. But then the problem for this one is when they advertise like this way, the size could be quite big. For example, here the function is is related to number of total nodes in the networks and number of Flux algo and number of links. If you have a router, usually a core router, it may have a few hundred links or 1,000 links, and you have 10 Flux algo. If advertisement adjacency is around n bytes, which is around 10 bytes, right? So it is about 100K bytes. So it's not a small RGB advertisement. So the question actually, can we make the advertisement even smaller? So what we try to do is, independent of number of links. That means we try to advertise something so that it reduces independent of the number of links on router. Even if you have 1,000 of links or 10,000 of links, doesn't matter. So the scaling of the whole RGB advertisement for the whole network will be totally reduced. So in this case, for the comparative to our previous example, it will be only around 100 bytes instead of 100K. Okay, because we independent of no links. So what we do is just to advertise the offset for each of the adjacent sets for the per Flux algo. That means we don't advertise change the set completely. We just advertise offset instead. So everyone can be, router can use this offset to predict the other adjacent set from on the other router. So every node calculates just as this way. So in this case, it's reductions of the 100K to hundreds, right? So this way actually make the Flux algo adjacency is in a more predictable format. The result of this one actually also good for troubleshooting. That means when you see the adjacency, you can easily correlate that adjacency with which Flux algo it belongs to. So from troubleshooting perspective, it's also very easy to achieve. So here is a kind of example. I think people knows about this one. In Algo 0, that means there's no Flux algo. Between this node 109 and 111 is advertised adjacency 32. This 32 is being shared among all Flux algo. So when we have Flux algo 128, 129, when we refer to this this adjacency, they will all share this one. In this case, that will be a problem when we actually forming a stack. For example, from this node, try and send a packet to 116, and then we include this 32. Okay, if this is the Flux algo 0, it's algo 0, not Flux algo 0, and then it's fine. But if this is a Flux algo, then this 32 cannot indicate which Flux algo it will be. So it becomes a trouble. So what we try to do is just advertise something, offset, which is same level of router, segment routing capabilities, that portions, it will just advertise an offset. Okay, so for example, for Algo 129, I will advertise a base offset of, for example, label offset is 2000. So what does it do is, which is in the next slide, this is a label stack actually. I mean, sending from this one was similar to the previous one, but this one is using Flux Algo 129. So you see that the prefix, the label is beginning with 402 instead of 400. So 402.1109 is this label stack is just like is the first label, and the stack is actually continue with this 2032. This 2032 actually is the kind of summation. I mean the sum of the Algo 0 and the offsets. That means it's a 32 plus the 2000, which is the offset advertised by this router 109 here. 109, this router will advertise this offset to the other router. And 106 can use this information to predict what kind of adjacency actually between 109 and 111. And this one becomes 2032 in this case. And then if each of the router, what's the benefit of this one actually? Each router just take a look at the top labels in the stack. They can identify the Flux Algo slice and actually apply some, a policy over there, right? So this is a purpose of having different adjacency for different Flux Algo. So this one is like a predictable way. So in this case, for example, like Flux Algo 128 or 130, they may become a 1032. For 130 is 3032, maybe from this one, the advertiser offsets. So everyone can predict the other adjacencies actually by this way, which is simple. So it reduces a lot of the advertisement from within the IGP itself. And also it can be actually extended to across, different areas, L1, L2, and also can save the kind of, advertisement as well. So but then the prerequisite of this one is you allocate the label in the kind of block in this case. For example, if you target to use the, for example, Algo 0 is 3233, okay, for the adjacency, you're going to plan to allocate. Then actually you should reserve the, the labels for Algo 128, 1032 or 1033 at the same time. And for Algo 129 is 2032 and 2033 in this case. You need to, in your adjacency local kind of block, a label block, you should reserve like this way, so that it won't be used by the other cases. But of course, you have some other method to make it more complicated, right? So they can reuse this kind of label, but I think this is not out of these discussions. But anyway, this is how the way that it will predict the other labels in this case. At the same time, we will talk. We have another offset, right, which is for the prefixes. That means you can use the same method to advertise a prefix offset for Flux Algo. That means you have a noxid or prefixes. You can also use the same method to just advertise offsets in this case. The saving of this one is a bit less, but there's other meanings of this one. Later on, if people want to ask, I would try to explain what is the reason of this one. The saving for prefixes offset will not be very big, but there will be other meaning. For example, if I want to expand the Flux Algo, to more than 128, then this one will be useful to you have this one actually. So I think this is my last slide. Any questions on this? Simple?
Yeah, I do, I guess. It's AC Lindum Cisco Systems. So it's an offset. The offset is automatically based on the algorithm. What if that would mean that you would have to advertise all the adjacencies in algorithm 0 so that you'd know where you're taking the offset from.
Yes, that's right.
You couldn't have algorithm 0 would have to be a complete superset, right?
That's right. That means you must have Algo 0 to be advertised. I think that is normal, right? Everyone do that Algo 0 advertisement, right?
But you'd have to include every adjacency and everything in it. Okay.
That's right. That's right. Yeah, correct. And then, but yeah, you can have the router can optionally advertise whether it has this kind of capability or not. the 109 this router can advertise 128, 129, but it don't care about 130. Then it don't advertise 130. Then the other router will know that okay, you will not going to use those kind of offset for Flux Algo 130. 130 maybe still use the Algo 0 kind of label in this case. Right? So that means it's per Flux Algo advertisement in this case. But once it's advertised for that router, it being like global informations, right? That means it means all the links within that router should have that kind of offset being added to it in this case.
Okay, thanks. I'll let the other
Casey,
people put their comments in.
Peter, you're up.
Yep, I just have a simple command. We already have a way to encode the Flux Algo HC. Now, if we are going to take this, then we need to stop the other one. We do not want to have two ways of encoding the same thing, please. So, for the working
The
group,
problem is that, I understand, right? It's very logical to use the other way, but the problem is the advertisement size, right? If you talk about 100 routers or even
no,
routers,
I'm not arguing. I'm not arguing your use case. What I'm saying is that the working group as such needs to decide which way of encoding are we going to standardize. We do not want to have two.
Oh, okay.
That's all.
Sorry. Right. Yeah. Sorry, I misunderstood. Right. Yeah.
Okay, thanks, Peter. Les.
I appreciate the scaling issue and your attempt to solve that because certainly if we have a node with 1,000 neighbors and you want to support multiple Flux Algos, that this can take up a lot of space. I'm just wondering, have you vetted this idea with any operators? Because it seems to me that this creates a deployment problem for the operators because they have to reserve, X number of SIDs, depending upon how many Flux Algos they think they might deploy in the future. So today, maybe they're only supporting 2, but they think in the future they might support 5. In order to avoid disruption, they're going to have to reserve a range of 5 for each of the adjacencies. Have you discussed this from a deployment?
Not yet, actually, not yet, right? But then actually the label space, local label space is not big actually. Here is 10 Flux Algo, 1,000 links. How many labels you have? You need 10K, right? So the label space is not a big problem. Maybe it's also adjacency. So you can change it. You can change it by configuration.
Yeah,
and reserve a local
I'm not
space.
talking.
I think it's fine, right? Yeah.
Sorry,
It's
Lou,
not
I'm not
global.
talking about the number of labels that you're going to need doesn't change. What you're trying to do is economize on the advertisement, which I think is something that would be good to do. But it creates a problem for the operator because now they have to anticipate, gee, how many consecutive labels do I have to reserve for each neighbor given how many Flux Algos I might deploy in the next 5 years? You see what I mean?
Yeah, I understand, but it really depends on the size of the router, and also it's because the local label blocks, right? So it's only per local router's configurations. It's not something a global one. Global is a problem, actually. I think if a global one, that's a problem, but it's local configurations, right? So local label blocks, right? You can change it anywhere,
I don't think
anytime,
it changed.
Right?
Anyways, I'm just suggesting I'd like to hear input from operators on this.
Yes.
Thanks.
Not yet. Sorry. Not yet. Not discussed with them. Yeah. That's right.
Thanks, Les. G.
Hello. Hello. Yeah. Hi, Luis. I have one comment on this document. I think here you assume that the offset is like a per algorithm parameter, so that it means for each Flux Algo, the same amount of the adjacent seed as the number of the seeds for the algorithm 0 will be reserved in advance. But actually, not every Flux Algo would require adjacent seed on every link. So this means some of this reserved seeds will be cannot be used for other purpose, right?
Correct. Yeah. Okay. I mean, I can answer it in these two ways, right? First of all, if you have 100 Flux Algo, 1,000 links, you only consume 100K labels. So it's not a lot, actually. You have 1 million label space, right? So I think from that one is fine. I mean, from the local, label space perspective, right? Yeah. And then the second one, actually, I mean, although yes, you're correct, actually. So as I said, when we allocate the label blocks, right? For example, like this way, okay. Supposedly the 2033 cannot be used, okay, because we reserved it, right? But as I said, actually, it will be you can using complicated kind of collect the label back, right? So this that this one not going to use, right? 2033 is not going to use anyway. You can put it back to your local label space if you want, but this is a more complicated kind of label management. Your local routers have to manage this one. This label can put back into use actually, because you're not going to use this one. Actually, Flux Algo is going to use that link, right? Because of Affinity, you avoid using that link, right? But you need to put it back into your local label space. So that is the solution for that one, if you really want to do that. Yeah.
Yeah, but that will be more complex for the label space management.
Yeah, but I said it's 100K
okay,
labels
we need
anyway,
to
right?
let's move on to the last person because we're kind of over time.
Yeah.
Okay. Let's talk more on offline.
White Quang? I don't know if I'm pronouncing that right. White Quang?
Hello.
Yes.
This is Wei
Yes.
Cheng from China Mobile. I think from operator point of view, the solution is valid. In fact, we also have a similar draft for SRv6. Here I have one question. How much can this solution reduce the advertisement smaller and make the advertisement smaller? How much? Have you
Well,
calculated?
yes, this is already estimated here in the problem statement slides, right? So it will be reducing from 100K to 100. That means the order is 1,000 if you have 1,000 links, right? But it really depends on number of nodes in the whole networks and number of links in the whole networks. So it is a function of number of link and nodes as well. So if the one case is extreme is 1,000, but if you have an average length in the network, maybe 50, right? Then you reduce around 50 in this case. So because this one independent of number of links for the routers. So this one, I think that will depend on average length per node. Per network. Actually, I would say average number of link per node per network. In this case, you can estimate that one. So it really depends on the network size.
Okay, that's good. Thank you.
All right. Thanks, Louis. I'm going to move on to the next presentation.
Thanks.
Thank you. Again, people interested, we should continue this on the list. Oh dear. Okay, I don't know why. Oh, let's see if it works. Who's presenting? Oh wait, this is not the right presentation, is it?
Can you hear me?
Yeah, I think we skipped over common address. So 1 second, sorry.
Okay. I have updated the slides. Can you share the new one?
This is broken, my interface. common address. Here it is. Jibo. Sorry about that.
Hello, can you hear me?
Yes.
I'm Zibo Hu from Huawei. My position is about the Comet JS RGB flash algorithm. Next page. Next slide, please.
You're controlling.
Oh, okay. I can see. Okay. Currently, flash eagles are manually identified using different IP addresses in that packet. This is no general approach for different flash eagles using shared IP address. The application of network slicing increases the number of flash eagles in the network. The development complexity would also increase due to the management and config for pair flash eagle IP addresses. An interface may belong to multiple flash eagle. This problem cannot be solved by associating spread interface with different flash eagles. This document introduces a generic approach to allow different flash eagles to share the IP address. Common address algorithm sub-TLV is defined to advise which common address the flash eagle the node passes pass in. Common address flash algorithm Flux in SRv6 located TLV is defined to indicate that the locator has the ability to be used for path calculations in multiple common address flash algorithm. Sorry, it's slow. This page is about the common address flash algorithm protocol extension. Common address algorithm sub-TLV is a sub-TLV of the root capability used to indicate which common address flash eagle the node passes path in. C-flag, common address flash algorithm flag in SRv6 located TLV to indicate the locator has the ability to be used for path correlations in multiple common address flash algorithms. This page is about the common address flash eagle counterplane. An example, links with different colors belong to different flash eagles, 128, 129, and 130. Each node describe participation in common address flash algorithm. For each flash eagle, each node correlations an SPF tree independently and generates an independent lib and fib using the same IP address. In the data plane, they already have a draft as 6-man enhanced VPN. VPN ID has defined a VPN ID hop by hop option to identify the network slicing resources. We can use the VPN option or use the topology ID defined in draft 6-man topology ID. Topology associated with flash eagle is encapped on the head end. The change node makes the forwarding table selection based on the topology ID, then forward packets according to the corresponding forwarding table. The comment.js Flux algorithm benefit is one, simplify Flux algo developments. No need attention IP address planning. Each Flux algo can share the same IP address. To reduce the protocol packet overhead, no need to advise IP address and SRv6 per Flux algo. 3. It can support per flow traffic splitting. Currently, the VPN seed has determined which Flux algo is selected. Therefore, the English PE cannot select different Flux algos based on the flows. 4. The Flux algo failed can be recovered to the basic IGP topology by changing the topology ID to the 0. It can switch over the basic IGP topology. Any comments are welcome.
Peter, go ahead, Peter.
Right. Okay, so the problem I see here is that this requires the packet classification on every hop. And that means you need to do that in the hardware. So, this has been tried with the MTR in the past. It failed. I'm not sure we want to repeat the same mistake here. And just one other thing, when we did the Flex algo design from the very beginning, one of our requirements always was that we didn't want to add any forwarding changes. We basically want to use the existing forwarding plane, being it labeled for SRMPLS or being it, IP or IPv6. So this basically makes the Flex algo requiring the changes in the forwarding plane, which I don't really am very optimistic about. So that's my comments on this.
Okay, Les.
In addition to what Peter has said, you cannot use topo ID in the forwarding plane to mark the packets because topo ID is scoped by the protocol. It's not a protocol independent identifier. So on top of what the concerns Peter raised, I don't think this works. Thanks.
Hello. I have
Similar
to
to Peter and Les is that we're solving a control plane. We're solving a configuration problem in the control plane by adding extra data plane separate fibs, which seems to be rather excessive. Also, I'm saying if somebody could do this without, I don't see why you couldn't do something like this independent of using, if you supported multiple topology, why you couldn't do this on top of it, running Flex algorithms and each Flex algorithm in a topology and reusing the addresses. I guess you wouldn't do anything to reduce the size of the addresses. But that wasn't explained, how to reduce the size wasn't explained very well in the draft anyway. That's my comment.
Hello.
Yeah. Hi.
Hi. Sorry, I'm to interrupt. I'm trying to help Jibo to answer some of the comments from the previous participants. The first about Peter's comments on the classification of packet on the network nodes. I think yes, we may have tried this with multi-topology routing in the past, but I think the capability of the hardware has changed since then. And as Jibo mentioned in the presentation, there have been proposals to introduce some new data plane identifiers either in IPv6 or the MPLS, so that it can, since we are already considering to change the forwarding plane, there is a possibility to introduce this topology identifiers as a one option for the data plane to help to the packet forwarding, so that we can save this addresses or seeds, and also the control plane resources for the advertisement of this information. So maybe we need to reconsider this, since the hardware has changed since the MTR routing design, right? And regarding last comment on the topology, actually, I'm not sure whether last means that we may need to introduce a different identifier for like a topology and algorithm. Is that if that is the case, maybe you can consider it further offline. Yeah. Okay, that's all.
I had a question specifically to what Les said too. Les, if you want to jump back on the mic, could you click? I didn't understand too. My question was about this topo ID. Is this being done in 6-man? Are they changing the V6 header to change forwarding based on a topo ID? Is that your understanding, Les?
I think the authors could speak to us. I believe they have a draft in 6-man that speaks to this.
Yeah, here are 2 drafts listed.
I would make the same comment on that draft, of course. A topo ID is a protocol-specific identifier. The ranges for topo IDs are protocol-specific. OSPF supports 127. ISIS supports 1024. There's no requirement that the topo ID for OSPF be numerically equivalent to the topo ID for ISIS if the 2 protocols are operating on the same topology. It's simply not an identifier that can be used for classification of packets.
But they, okay, yeah, I guess I didn't understand that, but there, I mean, that draft, it says IETF 6-man, so it's been adopted. So I guess that's what G was saying, is that there's an option now in the V6 forwarding plane to scope addresses based on a VTN ID. That's interesting. Okay, there's a lot of people in the queue still. Peter, did you want to do a follow-up?
Yeah, just a quick response is that, you know, the fact that we have the more capable hardware doesn't make the MTR problem any easier. So, yeah, I don't really buy that argument, but sure, you can do it, you can try it. But the problem I don't understand here, why are we worried about the number of addresses? I mean, this is IPv6, we have plenty of them. What's the problem we are trying to solve?
I had the same question.
Yeah, I think, sorry to interrupt again. Actually, it's not about the number of the issue is not only about the number of the addresses needed. It's also about we need to advertise these addresses in the protocol. Like the previous presentation mentioned, this is one issue this document tries to solve. And there are also other issues this document can solve, like the coupling between the services and the per algorithm locator, so that we can have the flexible service steering and also the switch over from one algo to the other algorithm. Well,
that it's in itself has issues. I'm not going to comment on that. That is very dangerous thing to do. But aside, I think the solution here is going to create more problems than the problem that we are trying to solve.
Yeah, maybe we can elaborate on what other problems introduced.
I guess we should take this to the list at this point. There's some interesting bigger concepts I think to discuss here. And I don't want to lose Peter's point of that. He said that, you know, the original design of Flux algorithm was specifically not to do something like this, right? So the working group should also consider that. AC, did you have something to put in before we move to
I had something really quick. Yeah, the VTN algorithm in 6-man is to use it for a VTN. I don't think you could just say, okay, let's hijack this, and all of a sudden it can be a VTN or a Flux algorithm. I mean, that would have that's then what if you want to have there's this multiplicity thing. What if you want to have Flux algorithms in that VTN? You know, then you're talking about maybe adding multiple identifiers to the packet instead of one. I mean, you just can't make that extension just because there's a draft.
That's called
for
tunneling.
VTN. Yeah. Just because you're doing a draft for VTN doesn't mean that you could use it for Flux algorithm as well.
Okay. Thanks. How do I get this? Okay. I think my agenda is different. That's why I got confused last time. So next up is exclusive link. Leon?
Yeah, I'm here.
You should have control of the slides.
Yes,
Go ahead.
but sorry, the slides has been updated through the email. Could you please share the new one? Because this draft has been updated, so we update the slides accordingly. Thank you.
Yingzhen, is this not the newest? Is that what I'm hearing? Should we do something crazy? Did I screw up?
Okay, how about we do the next presentation first and then come back to this one? And meanwhile, I can upload in the background, see what we can do.
Okay, that sounds great. That's what we'll do.
Okay. The next one is also B. So you can skip these two.
Okay, so we got to update the extensions SRv6 SIDs using SID block and exclusive links. So on to the service SID. Slides. Service SID. Who's presenting this? Chen Wang? Yeah. Okay, let me transfer the control to you.
Hello everyone, this is Mengxiao Chen from New H3C Technologies. This presentation is on ISIS and Ospf V3 extensions to advertise SRv6 service seed. This is a 0.0 version individual draft. Okay. As described in RFC 5565, there are situations where it is required to establish connectivity between IPv4 islands across an IPv6 core. BGP-based L3 service is often used to solve this problem. The BESS SRv6 services draft defines procedures and messages for BGP-based L3 service over SRv6, which uses SRv6 services to interconnect PEs and form VPNs. For example, router A and C are both BGP speakers. Router C sends the IPv4 prefixes of islands 2 to router A, along with SRv6 and DT4 seed. When forwarding the IPv4 traffics from island 1 to island 2, router A encapsulates the payload in an outer IPv6 header, whereas the destination address is C's SRv6 seed. Then the packet traverses the IPv6 core and reaches router C. The outer IPv6 header will be decapsulated, and the inner IPv4 packet will be sent to island 2. However, for the IPv6 core not deploying BGP, like the campus network using ISIS or Ospf V3, there may also be requirement to interconnect IPv4 islands. Migrating IGP to BGP or all edge routers may not be the first choice. So this draft describes an IGP method using SRv6 service seed to solve this problem. Sorry, it's a little slow. Okay, here is the solution. The procedure is similar with a BGP-based solution. The edge router advertises IPv4 prefixes along with an SRv6 service seed in IGP. The ingress router encapsulates the IPv4 payload in an outer IPv6 header, whereas the destination address is is the SRv6 service seed provided by the egress router. The egress router decapsulates the outer IPv6 header and perform IPv4 table lookup to forward the inner packet. The edge routers must be SRv6 enabled, but the transit nodes only need to perform plain IPv6 forwarding. Another problem is about the traffic engineering in IGP-only networks. In the current shortcut solution, the head end uses the tunnel as a shortcut to the tail end in its local SPF tree. However, if only the traffics to prefix 1 need to be stewed via the T tunnel, the traffics to prefix 2 are forwarded along shortest path. In this case, shortcut may not work well, as it will steal all traffics to C via the tunnel. In addition, shortcut will influence the path to downstream nodes, which may bring troubles for fine granularity flow control. Here is the solution. The tail end advertises prefix with an SRv6 service seed and color. In the example network, router C advertises SRv6 prefix of site 1 in IGP, along with an SRv6 and DT6 seed and color 1. And the prefix of site 2 is advertised with color 2. On router A, there are 2 SRv6 policies. The color of site 1 matches policy 1. So router A uses the segment list of policy 1 and the end DT6 seed of router C to build the path. The packet is encapsulated in an outer IPv6 header and an SR header. Then the packet is forwarded along A to D to E to F to C. Router C decapsulates the outer IPv6 header and sends the inner packet to site 1. Likewise, the traffics to site 2 are stewed via SRv6 policy 2, and the path is along A to B to C. This slide shows the extensions for ISIS protocol. A new SRv6 service seed subtier V is defined in the draft. It is used to carry the SRv6 service seed when advertising prefixes. When the subtier appears, it means the associated prefixes can be accessed via the SRv6 service seed. If that seed or its locator is reachable, the receiver may create forwarding entries with relevant instruction that the packet will be encapsulated in an outer IPv6 header with the destination address being SRv6 service seed. In the IPv4 islands over IPv6 core scenarios, it is recommended that the IPv4 prefixes associated with SRv6 service seed are advertised with a metric larger than max metric. The ISIS color subtier V is also defined. The subtier V indicates that traffics to the associated prefixes should be stewed over the T path specified by the color. This slide shows the extensions for Ospf V3 protocol. They are similar with the ISIS extensions, so I just skip. Okay, the next step is to revise the draft according to feedbacks. We have received some very good comments and suggestions from Robert. One of the comments is that injecting IPv4 sites to IPv6 IGP may cause issues. We think we need further discussion about that. Any questions and comments are welcomed. Thank you.
I guess I'm in the queue. AC Lindum, Cisco Systems.
You're up.
Yeah, I mean, I didn't know that Robert had this comment. I guess I missed it, but that was my comment too. You said if it's an IPv6 core, you know, in BGP we have the combination of the concept of a VPN address family where you're just flattening it all out and putting the IPv4 prefixes into IPv6. Now, if you got an IPv6 only core, you're not going to want to do that. So I don't think this is the right. Anybody's going to want to use this solution. There's actually a draft for OSPF, an RFC for OSPF, where we support the translation. I know because I joined this later. I was an author. I should have had it before, but where we actually do the translation, where we advertise IPv6, IPv4 addresses in IPv6, and then you do it that way, and then similar to rather than a decap, you do the address translation. But in that case, they're IPv6 addresses. They're not it's not IPv4 addresses. So that's just my comment.
Yes, thank you. Very good comment. But I think in some small campus network, it may be still useful. And as I introduced in the slides, that it is recommended that the IPv4 prefixes are advertised with max metric, so it does not influence SPF in the core. Okay, thank you.
Left.
I'm just not clear on why we need new encodings for the IGPs. It seems to me you just want the IGPs to advertise the new type of SID that hasn't been explicitly specified in the existing specifications. But I don't see why the existing advertisements can't be used to do that.
Sorry, I didn't get your question. You means we don't need the new subtier V to do the
Correct.
function.
Correct.
Oh, okay.
Okay, well, that's something we can explore more on the list, I guess, right? You can come back
Okay,
with
okay,
an
thank
answer
you.
to that if you want.
Okay, we
I
will
was
follow
just
up.
going to say real quick that
Yes.
RFC I was talking about that already exists is 6992.
6992. Okay, thank you. I'll read that draft for details. Thank you.
Okay, thanks. All right, let's see if we, where was our exclusive links?
Hi.
Hi, you're up. You should have control.
Yeah, thank you. Hi, this is Lian, and the topic I'm going to talk about is advertising exclusive links for Flux Algo in ITP. Sorry, it's a little slow. Okay. As we all know, Flux Algo allows ITP to compute a constraint-based path. And in some scenarios, the specific links will be associated with the Flux Algo. And these links should not affect the default topology. However, according to the current SPL calculation rules, these links are also included in normal SPL calculation. So the final routing table of the default topology will change, and the flows will be misdirected along the specific links. So this draft proposes a new method to exclude the Flux Algo link from the normal SPF calculation. This slide shows the typical scenario of the problem. Flux Algo 128 is newly deployed for the network slice, and it is associated with a new subinterface, which is with the red color, as the picture shows. And it is expected that only the particular flow belongs to the network slice should be steered along the red links. However, the newly added subinterface are also contained in the default topology and is used by normal SPF calculation. So the flows of the best effort service for the default topology may be steered into the red links if the ITP cost of the subinterface is smaller than the main interface. Oh, sorry, this is still the old version. The draft has been updated through the mailing list discussion, and the updated draft describes two solutions. Solution A uses the existing mechanism about advertise maximum link metric, and in combination with the existing draft, to avoid the Flux algo cannot use the ITP metric as its metric type. And this slide shows the second solution, solution B. It's using the protocol extension mechanism, define a new subtail way to indicate the link should not be calculated by the default SPF calculation. So this slide shows the detailed format of the ISIS subtail way. So I want to also express that about the solution A, the maximum link metric. There is some points to be considered. First, I think that for ISIS, because the RFC 5305 has defined that a link of maximum link metric must not be considered during normal SPF calculation. So I think it can be applied to these scenarios. It means that the maximum link metric mechanism works well for IIS protocol, but for OSPF protocol, according the current OSPF RFC, a link of maximum link metric is still reachable. It's not unreachable, similar with the IS. So we think that the maximum link metric mechanism does not work well for OSPF.
I guess so. So my comment is that given that the biggest problem with that last draft is backward compatibility, it doesn't really make sense to do it for ISIS.
I'm trying to AC.
Just what?
I'm trying to pull up the slides. Folks, this is why you can't send us slides like the morning of the thing, right? I mean,
oh.
Okay. Did you wanted to speak to solution A? Is that right?
Yeah.
I'll let her finish then.
The newest. Yeah. Thank you.
Okay.
Oh, okay. I see that the draft has been changed to just my comment, or not the draft.
Yeah.
The draft hasn't been changed. The slides have been changed.
Yeah.
Right.
So this slide shows the some points about solution A. So the first one is the ISIS, it works well, and the second one, we think it does not work with OSPF protocol. And the third one, when we use the maximum link metric mechanism, combination of the other solution should be applied according to the existing draft. We can define a new metric type, user metric type, so that the associated Flux algo can use the ITP metric in the past calculation. Okay, I can't control the slides. Could you help to? Yeah. Okay.
Yeah. Which one would you like? This one?
Okay. This slide is okay. This. So this is the solution B about the backward compatibility. As mentioned, AC. Thank you for your suggestion, and we updated the draft. So the mechanism we use is similar with the existing RFC 8024, and use the capability TLV to negotiation. and decide which one we should advertise. Next, please. Oh, that's all for the draft. And thank you for all the suggestions through the mailing list. And any further comments are welcome.
Okay, Les, you're up.
I've done my best to try to kill this draft on the list. The draft was created to solve an alleged problem with Flex Algo. There is no problem with Flex Algo. We have ways to exclude links. We have ways to define algo-specific metrics. That's also being greatly enhanced by the generic metric that's being proposed in the bandwidth constraints draft. There is no problem to be solved for Flex Algo. The only remaining question is for base Algo 0. Is there something that needs to be done for OSPF, not for ISIS? Because OSPF doesn't have the equivalent of max metric in as robust a fashion. That's a completely separate topic. It should be raised as a separate discussion. This draft should be abandoned.
Yeah, you've stated that a few times on the list. And I think the last comment I saw was, should we address this? I agree as a working group member. This doesn't, using Flex algorithm or putting it under the guise of Flex algorithm, or, I mean, if the problem is we want to exclude links from the base forwarding path, right? Let's solve that problem, but let's not do it under the guise of Flex algorithm. That's weird.
So I want to confirm if you agree that the issue proposed in the draft does exist.
If the issue that you're saying is
this problem.
Oh, sorry.
Sorry.
Oh, I mean, it's what Les said, right? The only issue that seems to be there is to be able to exclude links from algorithm 0, right? From the standard forwarding. If that's the issue, then yeah, I think you have agreement that that's a problem worth, or at least worth looking at. Whether it's worth solving or not, that would be a further question. Okay. Let's move to the next.
I guess I'm in the
one
queue.
Oh, you're in the queue, AC. I thought you were still in there. Go ahead.
Yeah. Okay. Yeah. I agree. It has nothing to do with Flex algorithm itself. And I think ISIS should be removed because of backward compatibility issues. Even if we were to do something for OSPF, there's no sense in doing something for ISIS just to have an analogous mechanism. Since there's already a mechanism and there's no backward compatibility, leave ISIS alone. For OSPF, I think the capability, if we were to do this, the capability, we could relax that so it would be up to the deployment whether or not they want to revert if everybody's not supporting it. Because in many deployments, because the max metric discourages use of the link, that's good enough. And that's my comment.
Okay. So SID block, I don't know if this one is going to also not be updated. I keep hitting the refresh thing, so I don't know if it's just not refreshing meeting materials or not.
Okay.
But we'll give it a try. Let's see.
Yeah. I'm in the queue. Could I say something, Chair?
Yeah, quickly.
Yeah. As one of the cause of the draft, I would like to confirm that. So the problem for OSPF is there, right?
Yeah, I think we've already covered that, right?
Yeah. So my question is that if that is a problem. Should we continue to update the current draft, or we should write another new draft to address OSPF problem?
Well, you've only gotten extremely forceful feedback from Les so far, saying abandon the draft. As a working group member, I haven't said that, but I agree that I don't think that solving the OSPF issue should be done with that draft, with this draft. So the one that was being presented a minute ago. Other people are going to need to chime in on the list. Maybe, please, people other than Les, maybe could throw some commentary on the list. But it does seem odd to solve, yeah. Anyway, let's move on to the next presentation.
Okay.
Okay, so same presenter, right?
Yes.
Hopefully this is the updated version. I don't know.
Oh, it's not the update version. Oh, just.
Is it going to be as problematic as the last one?
Yeah, it's okay. I can use this.
Okay.
Okay. This topic is about the ISI's extension to advertised SRv6 seeds using seed block. Sorry, it's a little slow. Wait a minute.
We can see the background slide.
Oh, I cannot see. Oh, okay, I can see it. And the IETF draft has defined the advertisement of the seeds, including and NX. And each subTLA contains a complete 128 bits. So in some scenarios, there may be a huge number of IND or NX. So considerable amounts of ISS-LSPs will be advertised, and we think that it's a heavy burden for ISP protocols. This is the detailed description about this problem. It should be noted that this is just a simple example to describe the scenario clearly. In the updated version, we give an complex example, so you can refer it after the meeting. And now I will explain this using this slide. So as we all know, multiple SRv6 NX seeds will be associated with the same P2P agency or the same physical LAN neighbors. So the number of the NX seeds is related to the number of the neighbors and also the number of the flavors. If the Flux Algo is applied, a node will advertise Flux Algo specific locator and along with the indexes for every link. So in these scenarios, the NX, the number of the NX will be increased into a large amount. So we can see this picture if the Flux Algo is newly added between A and B for network slicing. There should be 2 more NX seeds advertised for the newly added subTLAs. So when actually deployed, much more Flux algo will be used, 10, 20, even 128. And each physical interface will be sliced into multiple subinterfaces to support best effort rules. So the more Flux algo deployed and the more one router has the links, the more NX will be advertised. For example, if there are 10 Flux algo and each router have about 100 links, the final size will be about 48,000 ops. So this draft proposes a method to reduce the ISP number. First, we use the concept of the Azure V3 seed local block. It's composed of a number of continuous seeds within the address range of a locator. And second, the seeds assigned in a SRv6 seed local block is represented by its index in the block. And third, the offset value of the index is used to determine the position of the seed for the index. Finally, instead of advertising the complete 128-bit seed, and 16-bit index value is advertised in IGP. This is also a simple example of the solution from this slide. The seed can be replaced by local block and index with the offsite. This slide shows the detailed format of the new subTLV. First is the local block subTLV. It is carried in the SRv6 locator TLV. It contains the block ID and the start seed, end seed. And the other is the index subTLV of index, and it contains the block ID it refers to and the index also associated with the endpoint behavior. This is the format of the len index and the end seed is similar with the index seed. So I will skip it. Take this simple scenario as an example. This slide shows the detailed TLV of a router advertised for this topology. And first, the two different local block subTLV are included in different locator TLV. And second, the separate index value is used to represent the index seed separately during the index subTLV. This is the comparison of the TLV size. After the optimization, the size will be reduced to about 1/3. So the overall optimization can reach 1/3. This means that as the number of the index increases, the comparison will be more obvious. Next step of this draft, first The terminology state block may be confused with the locator block. So here we would appreciate any suggestion for a better name, and welcome any other further review and feedback. That's all for this draft. Thank you.
Peter.
Hi, I have one comment here which is similar to what I said for the other draft, but here it's even more important. We already have the, well, it's almost an RFC. The SRV6 draft is in the RFC editor queue, just waiting for doing some of the references. We already have standardized way to advertise index seeds or whatever type of seed, or adjacency. Are we going to standardize another method? Well, I would rather not.
Oh, okay, I understand that. We think that we can use this solution as a supplement for the current advertised or current draft.
Well, we never have two ways of encoding the same information. So unless this is really, really, really critical, then I would rather not go this path to have two different ways of encoding the same information. Just my opinion. I leave other people to speak. Thank you.
Okay, thank you.
AC.
And more on the line Peter said, I was just to say as working group chair, and given the number of deployments, we would not do this in either of these two mechanisms for reducing the size of the advertisements. We wouldn't do either of them instead of the deployed solutions, because even I mean that's particularly true for SRV6, and maybe this isn't, even though we haven't published Flex algorithm yet, I mean there's multiple vendors that have been have implemented it and have have published interop and whatnot, or press releases. So I don't think we'd have either of any of these mechanisms to reduce the size that would completely supplant. So any document's going to have to really address backward compatibility.
Yes, thank you. I am very understand your concerns, and here we prompt this problem because it is very seriously when the SRV6 deployed, and the LSP number is really a great burden for the ITP protocol. So we want to resolve it. And about the solution, I think this is the first version of the draft, and maybe it's not the perfect. And we believe that through the discussion, we can find the best way to resolve it. But the problem we still think is very, very necessary to resolve it.
Is that, sorry, is that really highlighted in your draft? Because the feedback I'm hearing so far that you've gotten is that this is not critical, but is pretty disruptive. So if you do have if you have use cases that show that the solution that we have that's sitting in the editor queue is not sufficient, I think you're going to have to make that case pretty strongly.
Oh, as the slide shows, in the new latest version, we can see that even there is no Flux algo, the problem is also very seriously because the number of the LSP is a great number. You can refer to it and discuss it offline. Okay.
Do you mean the LSP and ISIS, the number of LSPs?
Yeah, the ISS LSP.
Maybe this is a good time to do our extension. Anyway, we've played around with making that bigger too in the past. The number of LSP segments allowed. All right. What Quinn?
Oh, okay. Yeah, thank you. So as a causer, I would like to have some clarification. So first one, I think I totally agree with you that it's a good time to have those extension because most of operators who have not deployed ISAV6. So if we can optimize the solution this moment, that would help for those operators who can deploy the optimized solution at the first time. The second one, I think currently I'm from China Mobile. In fact, we might critical issue when we hope to deploy the Flux Algo with ISAV6. As we discussed the MPLS draft just now. In fact, we have already hoped to deploy the solution in more than 1,000 nodes network. So the conclusion is that it cannot work because the advertisement load is too heavy. So that doesn't work. It's not the performance issue. It's it can cause a critical issue so that the solution doesn't work. So I think
yeah. So I hear your point. I'm curious, where was this discussion when we were doing the SRv6 document in the working group? I mean, we got it all the way to the editor queue, and now you're saying it's undeployable.
So I think currently the presentation, the slides is not the latest one. If you can download the latest one, if you consider a network with 100 nodes, each nodes have 100 links, and each link support 2 flavors. You can calculate.
Yeah, no, I understand. I'm asking. I mean, the SRv6 stuff that's just about to get standardized has been worked on for a while. Why do we have a new solution showing up now? You know, like, why wasn't this is a working group document for a while, right? Why weren't we addressing this problem earlier? It seems like a failure. Okay.
Yeah, I'll just go back to what I said. We're not going to pull ISIS off the RFC queue. So any solution has to address back the SRv6. Any solution is going to have to address backward compatibility.
Yeah, so I think we should consider the backward compatibility. So if you don't deploy the ISAV6 and the Flux Algo at the same time, I think that's okay. But if you want to deploy the both of them in a large network at the same time, you will meet critical problem. So I think problem there, we should solve that. Of course, we should consider the back forward compatible, but we have to solve the issue to go forward, right?
Okay, Peter, you're up, and then let's move on to the last presentation.
I guess I just want to mention what you started, Chris, is that we have RFC 7356, which solves this problem. Maybe it's time to use it.
Is that the extended LSP?
Yeah.
Yeah, cool. Sounds good to me. Okay, let's get to the last presentation. Thanks, Leon.
Okay, thank you.
Oh, this is a funny one. I'm sorry I pushed off to do it. Okay.
Hello, everyone.
Hi, Wemo.
Can you hear me?
Yes.
Hello,
Does say
everyone.
routing working group. Yeah.
I was talking about the
Interesting.
LSR V3 path equals protection. Let's have an overview of SR equals protection through example. Here, we have SR path from ingress node PE1 to egress node PEA. PEA has a locator and then has a seed A. This seed A may be a VPN seed. To provide protection for PEA, we select a backup egress node, PEB. On backup egress node PEB, we configure mirror seeds to protect PEA. After this configuration, backup egress node PEB will create a forwarding table for PEA. This forwarding table will contain an entry for a seed, such as seed A. So this forwarding entry will forward the package with seed A to the same destination, such as C2 as PEA. After this configuration, the IGP on backup egress node PEB will advertise the information for egress protection. This information contains mirror seed and PEA, which will be protected. This information will be advertised to every node in the area. So after P1 as a PRR receiving this information, P1 will compute a backup path from P1 to backup egress node PEB. When P1 detects failure of PEA, P1 will encap the package to PEA with mirror ID and send this package to backup egress node PEB. When backup egress node PEB receives this package, PEB will decap the package using the mirror ID to get the forwarding table for PEA. And then using the seed A to get the forwarding entry in this forwarding table, and then forward the package with seed A to the same destination, C2, as PEA. So let's look at the extensions to support this protection. Extensions to ISIS. Basically, we define a mirror seed sub-TLV in the existing TLV. This sub-TLV contains mirror seeds, and then the node to be protected. For example, in where this sub-TLV will contain the C mirror seed configured on backup equivalent of PEB, and then the PA. PA is the equivalent to be protected. This PA is indicated in a sub-TLV we call the protected locator node sub-TLV. Optionally, we have another sub-TLV for seeds. So the extension to Ospf is similar. We define an Ospf mirror seed sub-TLV. So this mirror sub-TLV will contain mirror seed and the node to be protected. This node to be protected is contained in protected node sub-TLV. And then an optional sub-TLV for seeds to be protected. And then I would like to receive comments from everyone.
So this is this work is being done in the routing working group, right?
Yes. This work we present many times in routing working group, and then we would get a comment from the LSR working group because we have extensions into IGP to support the egress protection.
Right. Yeah, I just wanted to call that out to everyone. This is sort of an exposure thing. We're exposing you to work going on in the routing working group that relates to LSR. Louis. Or Louis.
Yes, the question actually, why, I mean, you can use anycast to achieve the similar thing, but of course, if you anycast, then there's other complications. You might need SRT, I mean, some kind of TE, plus some protection so that it can swing, primary and secondary. So choose a primary and secondary, right? But anycast can solve this trouble as well. But why not consider anycast, which is, do not change any forwarding plane at all, or control plane at all? Yeah.
Yes, that's a good question. For egress protection, different ways. One way is you mentioned that using anycast. I remember that for the solution using anycast, there's some issues, and also those issues has been raised in the working group meetings.
Okay, this is AC. I'll go real quick. I see Louis is off the queue. You got my comments. The one that I think it would be good for people to hear is why you need both of the sub TLVs. Now, granted, if you only had one sub TLV.
Yeah, that's right. Yeah, very good comment.
You need to rename it. Yeah, you need to.
I think the second one is optional. I'm considering removing that one. That one will make things easier. You're right.
Okay, thanks. And Chris, you said this was the last. There's still one more presentation.
I screwed up and went out of order.
Okay.
We're jumping back to the .NET extensions to enhance that.
Okay, great.
Thanks, Mimo. Yushan, you're up.
Okay. Hi, Xuesong from Huawei. I will give a very quick introduction about our work on ISST extensions for enhanced .NET. This slide is just tries to provide some background for this work. As defined in RFC 8655, DANet is designed for applications which request extra high quality network transmission. The performance provided by DATnet queues could be expressed as three aspects. The first one is bounded latency, which means the minimum and maximum end-to-end latency from source to destination could be expected. And the second one is extra low packet loss ratio under different optional states. And the third one is an upper bound on out-of-order packet delivery, which could be reordered by the technologies introduced by DANet. And so three technologies are used by DANet to provide these qualities of services, including resource allocation, service protection, and explicit routines. Now in DANet working group, DANet enhancement is under discussion, which make people pay more attention to introduce new requirements and solutions to provide bounded latency in DANet. So this document, we just try to introduce the necessary attributes for DANet bounded latency, besides the TE metric that have already been defined in RFC 05, if I remember it's right, and RFC 7810. And here is our proposal. Some attributes, new attributes are introduced, including node attribute TLVs for DANet, including DATnet processing delay sub-TLV, and also link attribute TLVs for enhanced DANet, including maximum DANet reservable bandwidth, DANet available bandwidth, and also DANet time resource sub-TLV. All these attributes will be used to calculate a path which could satisfy the delay and resource requirement of a DANet flow, which has been introduced in the previous slide. And here is DANet processing delay sub-TLV. Some background about this. In DANet, we think per hop delay could be divided into three parts. The first one is link delay, second one is processing delay, and the third one is queuing delay. In RFC 7810, minimum and maximum link delay sub-TLV has already been defined, and the queuing delay is calculated based on the queuing mechanisms. So this document just defines the missing part, minimum and maximum processing delay sub-TLV. And also link attribute TLVs for enhancement DANet, including maximum and available DANet reservable bandwidth sub-TLV. Actually, maximum link bandwidth and the maximum reservable link bandwidth sub-TLV have already been defined in RFC 5305. This document just defines the bandwidth that could not be shared by other traffic engineering flows. So new sub-TLVs are introduced here. And also, because DANet request bounded latency, so we think a time dimension of resource should be considered in link attribute TLV. So we define DANet time resource sub-TLV. Because there are a lot of different methods of implementations, solutions about how to provide bounded latency. So we try to just abstract the common attributes requested by different methods and divided them into two types. The first one is time resource for logical queues sub-TLV, and the second one is time resource for time scheduling sub-TLV. Basically, the difference of these two parts is the first one is when the underlying technology is logical queue based on scheduling mechanisms, they request a branch of attributes. And another case is we introduce some time scheduling mechanisms. Some corresponding attributes will be introduced. And that is the existing work we have done, and we request comments from LSR working group. And if people are interested in this work, we could cooperate and work together. Thanks. Comments, please.
Hi. So speaking as the chair hat on, I spoke with the chair of DetNet, and he didn't think this had been presented there. And to me, it seems like, you know, this isn't just, I mean, you do refer to some of the DetNet RFCs, but there's some new stuff here, right? And I think you need to, you know, it needs to be presented there, and the concepts need to be agreed upon in DetNet, so that really when you're coming to LSR, we can refer back to, you know, IETF agreed upon, last called, so forth and so on, you know, concepts that you're bounded to things and your Q measurements and all this has been agreed upon as the right way to do it, right? The right way to model these things. That has to be done in DetNet, I think. And then the work in LSR is really just reduced to, we look at what's been agreed upon in DetNet and we say, okay, to deliver that, we use these sub-TLVs. But it seems like what you've got here are some sub-TLVs that are also creating new concepts, right? And I don't think you can, I don't think it's right to do that in LSR. And with,
yes, understood. I think this is reasonable. We will bring this work back to DetNet, of course, because we want to introduce it in LSR first is because it is very related to the previous work that have already been defined in traffic engineering metric extensions in LSR. So I think maybe people will be interested in this work when it's still in its maybe start point. So just to collect more attention here, if to see if people are interested or whether this is reasonable. Yeah, but of course we will go back to DetNet first.
okay, thanks. Les, you're up.
Chris, I agree with you, but I really want to expand on the point you're making, because it seems to me that I haven't spent a lot of time looking at DetNet documents, but I have looked at them somewhat, and I do not see that DetNet has a defined role for the IGPs in a DetNet network. And yet here we are jumping ahead and going, oh, let's use the IGPs to flood a bunch of link attribute information that may be useful to DetNet. I really think we need to have a much better liaison between the two working groups and come to some agreement on if there is a role for the IGPs in DetNet and what that should be. And I'm kind of hoping that you, the chairs, and John, who I believe happens to be AD for both working groups, can facilitate that. That's my comment.
Yeah, sure. Because we also were in DetNet, we are working on the control plan framework document, and in that document, that will introduce the general requirement for control plan protocols. So maybe IGP will be also included. I think that is another opportunity to connect these two working groups. And
which
sounds
to me
like
reinforces it reinforces the fact that this draft is very premature.
Yes, I agree. Okay. Because
Good.
there are
although
still
perhaps it's done its job and got the attention of Les and others.
Yeah, that's great. That's great. Please review it.
Okay. Okay. Oh, I'm done, and I think Les is done. AC, you're up.
Yeah, the only comment I had is I haven't been following DetNet much at all, but the unit seemed a little bit strange to having it bytes per second and a 3 octet field. That's not consistent with IGPs at all, and I'm wondering where that came from. You don't have to answer that now. You can answer it once you get the question of vetted in DetNet and established that it needs to be this DetNet information needs to be advertised in IGPs. But that's something you should think about too. Is it seems pretty strange to do bytes per second and only a 3 byte metric, because that
I'll
only
be
allows
more.
for
I'll
only
be
like
more. It's
164
not enough.
bits per second, or no, not 108 times
It's
24
not.
meg, whatever that is. So
It's not
something
enough.
like
It's not, AC. It's not enough. You're right. It's that simple.
Okay. We will consider
I mean,
this.
it's bits and
Mhm.
bytes, right? So all you have to do is say it's a 32 bits per second field, which means you're at 4 gig, right? We have 400, 800 gig links coming, right? So
Yeah.
it's like a couple of magnitudes too small.
You're right. You're right. Well, I think this could be considered. In the next version, we will consider whether the field is reasonable enough.
Okay.
We
AC,
made it
any
through
closing
everything.
comments?
Yeah. Just on
Thanks,
time.
thanks, Yusong.
Thank you. Thank you.
Thanks. Yeah, we did. It's noon. Well, somewhere.
Yeah, 12. Okay, so we got a lot to discuss on the list. We won't keep people here beyond the end time. Thanks everybody for participating, and thanks to all the presenters for preparing their slides and presenting today. I'm glad we could catch up on all these drafts that we didn't get to in 114.
Yeah. Okay, and hopefully see a lot of you in London. It's nice to be seeing people in person again. Awesome.
Yeah.
All right, everyone. Thanks.
Thanks.
Bye-bye. Hank, I hope you kept good notes.